Hello, this is Schedulytics. Welcome to today's session. In today's brief video, we're taking a look at concept correlation analysis. We will demonstrate this using JASP, and as we do, we'll come to appreciate its application when it comes to research. Now, you would attest to the fact that, or agree with me, that when we observe phenomena such as age and height, you will come to the conclusion that as one advances in age, his or her height tends to increase until a particular threshold is attained. Now, for us to statistically establish the relationship that exists between height and then age of an individual, we would employ what we call the correlation analysis. This correlation analysis will help us to establish the relationship that exists between these two varying variables. Now, if you watch this video right to the very end, you'll be able to know some statistical tools that will be used in doing that. For example, JASP. You would also be able to know how Pearson correlation coefficient relates with covariance. And what is more, you would be able to know the difference that exists between correlation analysis and chi-square or contingency table analysis. And so we encourage you to watch this video right to the very end. If possible, subscribe to the channel, like the video, and share with all and sundry. Now, let's begin. Correlation analysis, what is it all about? Well, correlation is basically a statistical method that is employed to ascertain whether or not pairs of variables are associated, and also to establish the strength of that association. Now, in doing this, there are keynotes that one has to pay attention to. One is the fact that correlation analysis is done on continuous variables. And when we are encountered with categorical data sets, we would want to rather employ contingency table and or chi-square analysis. Now that brings us to the difference that exists between correlation analysis and chi-square or contingency table analysis. Well, the difference is that whilst correlation analysis focuses on continuous variables, chi-square table or contingency table or chi-square analysis focuses on categorical data sets. Now, in doing correlation analysis, there are a few questions that one needs to ask him or herself. The first one is that, is there a similar change that occurs in a variable as it does in another variable? The second question is that, does a variation or deviation from the mean in one variable result in a similar deviation in another variable in the same direction or in the opposite direction? Now, if you seek to find answers to such questions, then the right tool or test method or statistic to use is the correlation analysis. Now, there are a few assumptions that one has to take note of, and that is the fact that the data set should be normally distributed or linear. However, when you have a data set that is curvilinear, it may be a challenge to accurately use correlation analysis in that regard. The null hypothesis that is tested for whenever we are undertaking correlation analysis is that there is no association between the two variables that are being considered or compared. Now, once one undertakes his or her correlation analysis and results are given, how does one interpret this? First of all, one has to know that the correlation coefficient ranges from -1 to +1, and that whenever R is close to +1 or -1, then we can say that these variables are closely related. However, if we have values of R being 0, then it helps us to see that there is no association between these two variables. Now, in which situation would we want to consider covariance, or how is covariance and Pearson correlation coefficient related? Well, for one thing, covariance differs or changes whenever one uses or changes the unit of measurement of a particular quantity. And so for us to standardize that difference that would occur whenever we change the unit of a particular quantity under consideration, we employ the Pearson correlation coefficient. So the Pearson correlation coefficient is more of a standardized way of presenting variations that occur in variables, which covariance can equally do. But because covariance changes whenever there's changes in the unit of measurement of a particular quantity, we want to fall on the standardized one, Pearson correlation coefficient, which we'll call in this regard R. Now, having established this theoretical basis and background about correlation analysis, we now want to step into the JAS platform and see how we can practically apply our theoretical knowledge that we have just discussed. So let's go to JAS and practice. Good, so now we are right here on the JAS platform. So we'll come and load our data set. We'll click on this button here, and then we'll go to open. Then we'll navigate to our computer, and I've saved that document on the desktop. So I'll click here and then locate correlation 2, and then I'll click on open. And then within a few seconds, our data set is loaded. So this is a data set involving creatinine, uric acid, low density lipoprotein, a very low density lipoprotein. Now I'll select 2 of these variables, uric acid and low density lipoprotein, and then try to see whether it is normally distributed by running the Chavarro-Wick normality test. And here it says it is insignificantly different from a normally distributed data. So hence, our data set is normally distributed. It passed the normality or the assumption test. And so we can use this to demonstrate what we are intending to do, which is the correlation analysis. So we'll click on, so we can delete this, and then we'll select, we are looking at correlation. So we'll go to regression, and then we'll select correlation, and then we'll load our variables to the variable column. And then we have opportunity to select between Pearson, the Pearson R, which is the Pearson correlation coefficient we discussed. And then we have opportunity to select what displays here. Now, in a brief moment, we'll see how these variables or these options play out. Meanwhile, we also need to settle on a particular alternative hypothesis. Having established that the null hypothesis is that there's no association between the 2 variables, the alternative hypothesis is that there is an association. Now, the other one is that there is a positive association, and then the other one, the last one, is a negative association. We'll select the first one for the purposes of demonstration. However, depending on what you are testing for or what your alternative hypothesis is, you may want to change this particular field or space here. Now, based on our results here, we are able to tell that this p-value is 0.05. And since our alpha value is at 0.05 and the p-value is equal to it, we will fail to reject the null hypothesis. And looking at the Pearson correlation coefficient is 0.14, which is also close to 0. So we can say this is a positive weak association between the 2 variables. However, it is not statistically significant. Now, should you want not to have this particular space or dash here, and for you to have the data displayed pairwise, you will just check this, and then it gives you a very simple display of your result. So this is telling us that between uric acid and low density lipoprotein, they are not significantly associated. However, there's a positive association that one can find, but that association is weak because it is close to 0. This is how one can be able to run a correlation analysis for any given variable of choice, continuous and normally distributed. Well, if you have any question, we encourage you to comment or to leave them at the comment section, and we would address them one after the other. This is Schedulytics. Until we meet again, it's a bye.